Azure Virtual Machines, or VMs, represent a cornerstone of cloud computing, offering a flexible and powerful solution for businesses and developers alike. These virtual machines provide infrastructure as a service, or IaaS, giving you the capability to create and manage virtualized servers in the cloud. Think of an Azure VM as a digital equivalent of a physical computer, complete with virtualized hardware resources. This setup allows you to install almost any software that runs on that OS, giving you remarkable flexibility in your cloud environment. One of the key advantages of Azure VMs is the level of control they offer. You have complete authority over the operating system, allowing you to choose and configure the OS that best suits your needs. This control extends to the software running on the VM, enabling you to install custom applications or specialized software that may not be available in more managed cloud services. Azure VMs shine in scenarios where you need custom hosting configurations. Whether you're setting up a specific development environment, running legacy applications, or configuring a unique server setup, VMs provide the flexibility to meet these diverse requirements. However, it's important to note that while Azure handles the physical hardware, you're still responsible for the software side of things. This means you'll need to handle tasks such as configuring the OS, installing and updating software, and managing security patches. This level of responsibility is part of the IaaS model, offering a balance between control and managed services. A powerful feature of Azure VMs is the ability to use pre-configured images. These images serve as templates, containing an OS and often additional software, allowing you to rapidly provision new VMs. This capability significantly speeds up deployment, enabling you to have a new server up and running in minutes rather than hours or days. In essence, Azure Virtual Machines offer a bridge between traditional on-premises servers and the cloud, providing the flexibility and scalability of cloud computing while maintaining the familiarity and control of traditional IT infrastructure. As we delve deeper into Azure services, you'll see how VMs can be integrated with other Azure offerings to create robust, scalable, and efficient cloud solutions. As we delve deeper into Azure's capabilities, it's crucial to understand how to effectively scale your virtual machine deployments. While single VMs are useful for testing, development, or minor tasks, many scenarios require multiple VMs working together to provide high availability, scalability, and redundancy. This is where Azure's advanced features like virtual machine scale sets come into play. Virtual machine scale sets represent a quantum leap in VM management and scaling. They allow you to create and manage a group of identical, load-balanced VMs with unprecedented ease. To appreciate the value of scale sets, let's consider the alternative: manually creating and managing multiple VMs. In a manual scenario, you'd need to ensure all VMs are configured identically, set up network routing parameters for efficiency, and constantly monitor utilization to determine if you need to increase or decrease the number of VMs. This process is not only time-consuming, but also prone to human error and inefficiencies. Scale sets, on the other hand, automate most of this work. They provide a centralized management interface where you can configure and update a large number of VMs in minutes. This centralized approach ensures consistency across your VM fleet and significantly reduces the potential for configuration errors. One of the most powerful features of scale sets is their ability to automatically scale. The number of VM instances can increase or decrease in response to demand, ensuring you have the right amount of compute power when you need it, without wasting resources when demand is low. Alternatively, you can set scale sets to scale based on a defined schedule, which is particularly useful for workloads with predictable fluctuations in demand. Scale sets also automatically deploy a load balancer, ensuring that incoming requests are distributed efficiently across all available VMs. This built-in load balancing feature further enhances the performance and reliability of your applications. The applications of virtual machine scale sets are vast. They're particularly well suited for large-scale services in areas such as compute, big data, and container workloads. Whether you're running a high-traffic website, processing large data sets, or managing a complex containerized application, scale sets provide the tools to do so efficiently and at scale. In essence, virtual machine scale sets embody the promise of cloud computing, the ability to easily scale resources up or down based on need, automate routine tasks, and focus on your applications rather than infrastructure management. As we progress through this course, you'll see how scale sets can be integrated with other Azure services to create robust, scalable, and efficient cloud solutions. As we continue our exploration of Azure's robust tool set for building resilient and highly available environments, we come to virtual machine availability sets. This feature is designed to ensure that your virtual machines can withstand various types of failures and maintenance events without compromising the availability of your applications. Availability sets work by intelligently distributing your VMs across different fault and update domains within an Azure data center. This distribution helps to protect your application from outages caused by hardware failures, network disruptions, or planned maintenance activities. Let's break down the two key concepts that availability sets utilize. Update domains. An update domain is a group of VMs that can be rebooted at the same time. When Azure performs planned maintenance, it processes one update domain at a time to minimize the impact on the applications running on these VMs. After an update domain is processed, Azure gives the VMs a 30-minute recovery period before moving on to the next update domain. This approach ensures that at least some instances of your application remain available during the update process. Fault domains. A fault domain represents a group of VMs that share a common power source and network switch. By default, an availability set splits your VMs across up to 3 fault domains. This distribution helps to protect against physical hardware failures, network outages, or power interruptions. If a fault domain goes down due to a hardware or network issue, the VMs in the other fault domains can continue to run, maintaining the availability of your application. The diagram in our slide illustrates this concept visually. The large rectangle represents the availability set. The 3 vertical sections represent update domains, UD1, UD2, UD3. The horizontal lines divide each update domain into 3 fault domains, FD1, FD2, FD3. The small rectangles represent individual VMs, distributed across both update and fault domains. This arrangement ensures that no single point of failure can take down all of your VMs simultaneously. If a hardware failure affects one fault domain, VMs in the other fault domains continue to operate. Similarly, during planned maintenance, only one update domain is affected at a time, allowing your application to continue running on the VMs in the other update domains. One of the most appealing aspects of availability sets is that there's no additional cost for configuring them. You only pay for the VM instances you create. This makes availability sets a cost-effective way to significantly improve the resilience and availability of your applications. When designing your Azure infrastructure, it's crucial to consider which VMs should be placed in the same availability set. Typically, you would group VMs that perform the same role in your application. For example, if you have a web application with front-end and back-end servers, You might create one availability set for your front-end VMs and another for your back-end VMs. By leveraging availability sets, you're taking a proactive approach to high availability, ensuring that your applications can withstand various types of failures and maintenance events. This feature, combined with other Azure resilience tools we've discussed, allows you to build robust, fault-tolerant applications that can meet the most demanding availability requirements. Azure Virtual Machines offer a versatile and powerful solution for a wide range of computing needs. Their flexibility and scalability make them suitable for various scenarios. Let's explore some common use cases where Azure VMs shine: testing and development. Azure VMs provide an ideal environment for testing and development purposes. They offer a quick and easy way to create different operating system and application configurations. This flexibility is invaluable for development teams who need to test their applications across various environments. The beauty of using VMs for this purpose is that they can be easily created, modified, and deleted as needed. This approach saves time and resources compared to setting up physical hardware for each configuration. Once the testing or development work is complete, teams can simply delete the VMs, ensuring they only pay for the resources they actually use. Running applications in the cloud. Moving applications to the cloud can offer substantial economic benefits, and Azure VMs are an excellent platform for this purpose. One of the key advantages is the ability to handle fluctuations in demand. For instance, an e-commerce application might experience sudden spikes in traffic during sales events. With Azure VMs, you can quickly scale up by starting additional VMs to handle the increased load, and then scale down when the demand subsides. This elasticity ensures you only pay for the resources you need when you need them. It's a far more cost-effective approach compared to maintaining an on-premises infrastructure sized for peak loads. Extending your data center to the cloud. Azure VMs offer a seamless way to extend your on-premises data center into the cloud. By creating a virtual network in Azure and adding VMs to it, organizations can expand their network capabilities without the need for additional physical infrastructure. This hybrid approach is particularly useful for applications that might be challenging or expensive to run on-premises. For example, you could run SharePoint on an Azure VM, leveraging the cloud's scalability and reliability while maintaining integration with your on-premises systems. This strategy can lead to significant cost savings and increased flexibility compared to a purely on-premises solution. Disaster recovery. Disaster recovery is a critical concern for any organization, and Azure VMs provide a cost-effective solution. Traditional disaster recovery often requires maintaining a duplicate set of hardware in a secondary location, which can be expensive and resource-intensive. With Azure VMs, you can instead create a cloud-based disaster recovery solution. In the event of a failure at your primary data center, you can quickly spin up VMs in Azure to run your critical applications. Once the primary site is operational again, you can shut down the Azure VMs. This approach ensures business continuity without the need for a permanent secondary infrastructure, resulting in significant cost savings. The diagram in our slide visualizes these use cases, with Azure Cloud at the center and the four main scenarios connected to it. This representation highlights how Azure VMs serve as a versatile solution, adapting to various business needs from development to disaster recovery. In all these scenarios, Azure VMs offer a combination of flexibility, scalability, and cost-effectiveness that can be challenging to achieve with traditional on-premises infrastructure. By leveraging Azure VMs, organizations can optimize their IT resources, improve agility, and focus more on their core business objectives rather than managing infrastructure. As we progress through this course, we'll delve deeper into how to implement these solutions using Azure VMs, ensuring you have the knowledge to make the most of this powerful cloud resource. As organizations increasingly embrace cloud computing, Azure Virtual Machines, VMs, offer a seamless path for transitioning from on-premises infrastructure to the cloud. This process, often referred to as lift and shift, allows businesses to migrate their existing workloads with minimal disruption and modification. Let's explore this concept and the resources associated with Azure VMs in more detail. Moving to the cloud with VMs. The lift and shift approach is a popular strategy for cloud migration, especially for organizations looking to quickly move their applications and services to the cloud without significant re-architecting. Azure VMs are particularly well suited for this approach due to their flexibility and similarity to physical servers. Here's how it typically works. Create an image. The first step involves creating a digital image of your existing physical server. This image captures the entire server environment, including the operating system, applications, and data. Minimal changes. One of the key advantages of using VMs for migration is that you can host this image within an Azure VM with little to no changes. This means your applications and services can continue to run in the cloud environment, much as they did on premises. Maintenance responsibilities. It's important to note that, just like with a physical on-premises server, you remain responsible for maintaining the VM. This includes tasks such as updating the operating system, managing security patches, and maintaining any installed software. This approach offers several benefits. Rapid migration. You can move your existing workloads to the cloud quickly with minimal downtime. Familiarity. Your IT team can continue to work with familiar systems and tools. Flexibility. You can gradually optimize and modernize your applications after the initial migration. VM resources. When you provision an Azure VM, you have the flexibility to choose various resources that will be associated with that VM. These resources allow you to tailor the VM to your specific needs. Let's look at the key resources you can configure. Size. Purpose. VMs come in various sizes optimized for different use cases. General purpose, compute optimized, memory optimized, etc. Number of processor cores. You can choose VMs with different numbers of CPU cores based on your computational needs. Amount of RAM. Memory allocation can be adjusted to suit your application requirements. Storage disks, hard disk drives, HDD. Suitable for bulk storage and workloads where data is accessed infrequently. Solid-state drives, SSD, offer faster performance and are ideal for I/O-intensive applications. Ultra disks provide extremely high disk throughput and IOPS with sub-millisecond latency. Networking. Virtual network. You can place your VM within an Azure virtual network to communicate with other services securely. Public IP address. You can assign a public IP if the VM needs to be accessible from the Internet. Port configuration. You can configure which ports are open and accessible, enhancing security. The diagram in our slide illustrates this concept. On the left, we see a representation of a physical on-premises server. An arrow labeled Lift and Shift points from the physical server to the Azure cloud, represented by a large rectangle on the right. Within the Azure cloud, we see an Azure VM, symbolizing the migrated server. Around the Azure VM, we see circles representing the key VM resources, size, storage, and network. This visual representation helps to conceptualize the process of moving from a physical infrastructure to a cloud-based one, while also highlighting the key resources you can configure for your Azure VMs. By leveraging Azure VMs and carefully selecting the associated resources, organizations can effectively migrate their existing workloads to the cloud, setting the stage for future optimization and innovation. As we progress through this course, we'll explore in more detail how to select and configure these resources to best meet your specific needs and objectives. In this task, we'll walk through the process of creating a Linux virtual machine in Azure and installing the Nginx web server. This practical exercise will demonstrate how to use Azure CLI commands to set up and configure a VM, as well as how to leverage the custom script extension to automate post-deployment tasks. Let's break down the process into two main steps. Creating a Linux virtual machine. To create a Linux VM, we'll use the azvm create command in Azure CLI. Here's the command. After running this command, Azure will take a few moments to create your VM. The name myVM will be used to refer to this VM in subsequent steps. Installing Nginx using custom script extension. Once the VM is created, we'll use the custom script extension to install and configure Nginx. The custom script extension is a powerful tool that allows you to download and execute scripts on your Azure VMs, making it easy to perform post-deployment configuration tasks. In this case, we're using it to automate the installation and basic configuration of Nginx. The diagram in our slide illustrates this process. We see the Azure cloud represented by the large rectangle. Inside the cloud, we have a Linux VM represented on the left. On the right, we have Nginx represented as a separate component. The arrow between them represents the custom script extension, which is used to install and configure Nginx on the Linux VM. Now, let's walk through the hands-on steps to create a Linux VM in Azure and install Nginx. Open Azure Cloud Shell. Start by opening Azure Cloud Shell in your Azure portal. This provides you with a browser-based shell experience that's pre-configured with the Azure CLI and other necessary tools. Create a Linux VM. Use the azvm create command to create your Linux VM. Let's break down the command. Resource group Learn It lessons. This specifies the resource group where your VM will be created. Name myVM. This sets the name of your VM to myVM, public IP SKU standard. This assigns a standard public IP address to your VM, image Ubuntu 22.04. This specifies Ubuntu 22.04 as the operating system for your VM. Admin username Azure user. This sets the admin username for the VM. Generate SSH keys. This automatically generates SSH keys for secure access to your VM. Wait for VM creation. Azure will take a few moments to create your VM. The CLI will display progress information and will return a JSON object with details about your new VM when it's ready. Install Nginx. Once your VM is ready, use the azvm extension set command to install Nginx. This command uses the custom script extension to download and run a bash script that installs and configures Nginx. Let's break it down. Resource group Learn It lessons and VM name myVM. These identify your VM. Name custom script. This specifies that you're using the custom script extension, publisher Microsoft Azure extensions, and version 2.1. These specify the extension publisher and version. Settings. This JSON string specifies the URL of the script to download. Protected settings. This JSON string specifies the command to execute running the downloaded script. Wait for Nginx installation. The custom script extension will download and execute the specified script. This process includes updating package information, installing Nginx, and setting up a custom homepage. Verify the installation. Once the installation is complete, you can verify it by accessing your VM's public IP address in a web browser. You should see a welcome page served by Nginx. Azure Virtual Desktop represents a significant evolution in desktop virtualization technology, offering a flexible and secure way to access Windows desktops and applications from anywhere in the world. Let's delve into the key aspects of this service. Cloud-hosted Windows. Experience. Azure Virtual Desktop provides users with a cloud-hosted version of Windows. This means you can access a full Windows desktop environment without needing powerful hardware on your local device. The processing and storage happen in Azure's cloud infrastructure, allowing you to use a consistent Windows environment from any location with Internet access. Cross-platform compatibility. One of the most powerful features of Azure Virtual Desktop is its ability to work across different devices and operating systems. Whether you're using a Windows PC, a Mac, a Linux machine, or even mobile devices running iOS or Android, you can access your Azure Virtual Desktop. This flexibility allows organizations to support bring your own device BYOD policies and remote work scenarios more effectively. Multiple access methods. Azure Virtual Desktop can be accessed in two primary ways. Remote desktop apps. These are client applications that you can install on your device to connect to your Azure Virtual Desktop. Modern browsers. For devices where you can install software or for quick access, you can use most modern web browsers to connect to your virtual desktop. Application virtualization. Beyond just providing a full desktop experience, Azure Virtual Desktop also supports application virtualization. This means you can make specific applications available to users without needing to give them access to a full desktop environment. This can be useful for organizations that want to provide access to certain software tools without the overhead of managing full virtual desktops. Security and compliance. Azure Virtual Desktop integrates with Microsoft's security services, providing features like multi-factor authentication, role-based access control, and data encryption. This makes it a suitable solution for organizations with strict security and compliance requirements. Scalability and management. As an Azure service, Virtual Desktop benefits from the cloud scalability. Organizations can easily add or remove virtual desktops as their needs change. Microsoft handles much of the underlying infrastructure management, reducing the IT overhead compared to traditional on-premises virtual desktop infrastructures. Windows 10. Multi-session. Azure Virtual Desktop introduces Windows 10 Multi-Session, a feature exclusive to this platform. This allows multiple users to log into the same Windows 10 virtual machine, providing a more cost-effective solution for many scenarios compared to traditional one-user per VM models. The diagram in our slide provides a detailed illustration of the Azure Virtual Desktop architecture. Azure Cloud. The large outer rectangle represents the Azure Cloud, where all the components of Azure Virtual Desktop are hosted. Virtual Desktop Infrastructure. Inside the Azure Cloud, we have a dedicated area for the Azure Virtual Desktop Infrastructure. This encompasses all the core components needed to run virtual desktops. Core components. Virtual machines. These are the actual virtualized desktops or servers that users will connect to. Storage. This represents the storage solutions used to maintain user profiles, data, and applications. Networking. This component handles all the networking aspects, ensuring secure and efficient connections. Management and orchestration. This layer is responsible for managing the entire infrastructure, including scaling, updates, and user assignments. User devices. At the bottom of the diagram, we see various devices that can connect to Azure Virtual Desktop: PC Mac, representing traditional computer access. Tablet, for mobile tablet access. Smartphone, illustrating access from mobile phones. Browser, representing access through web browsers without needing a dedicated application. Connections, the dotted lines connecting the devices to the virtual desktop infrastructure represent the secure connections established when accessing the virtual desktops. This comprehensive diagram helps visualize how Azure Virtual Desktop provides a complete, cloud-based solution for delivering virtual desktops and applications to users across various devices and platforms. It emphasizes the flexibility and scalability of the service, all while being securely housed within the Azure cloud environment. Azure Virtual Desktop is transforming how organizations approach desktop management and remote work. By moving desktop environments to the cloud, it provides flexibility, security, and efficiency that traditional desktop solutions struggle to match. As we continue to see shifts towards remote and hybrid work models, services like Azure Virtual Desktop are likely to play an increasingly important role in enterprise IT strategies. Azure containers represent a significant leap forward in cloud computing technology. These versatile tools offer a streamlined approach to application deployment and management, providing developers and IT professionals with unprecedented flexibility and efficiency. At their core, containers are a lightweight virtualization environment. Unlike traditional virtual machines, which emulate entire operating systems, containers share the host system's OS kernel. This innovative approach results in faster startup times and reduced resource consumption, making containers an ideal choice for modern, agile development practices. One of the key advantages of Azure containers is their ability to run multiple instances of an application on a single host machine. This capability allows for optimal resource utilization and cost effectiveness, particularly in scenarios where application demand fluctuates. Moreover, containers are designed with scalability in mind, enabling rapid deployment and easy management of multiple instances as your needs grow. Azure's container services are not limited to a single technology. While Docker is one of the most popular container engines, Azure supports a wide range of containerization solutions. This flexibility ensures that you can choose the tool that best fits your specific requirements and existing workflows. Azure containers offer a multitude of advantages that make them an attractive option for modern application deployment and management. Let's explore these benefits in more detail. First and foremost, Azure containers enable rapid deployment and scaling of applications. With containers, you can package your application and all its dependencies into a single unit, ensuring consistency across different environments. This capability significantly reduces the "it works on my machine" problem, streamlining the development and deployment process. Another key advantage is the consistent environment that containers provide across development, testing, and production stages. Developers can work with the same container image locally that will be used in production, minimizing discrepancies and potential issues when moving from one stage to another. Resource utilization is greatly improved with Azure containers. Unlike virtual machines, which require a full OS for each instance, containers share the host OS kernel. This approach results in lower overhead and more efficient use of system resources, allowing you to run more applications on the same hardware. Enhanced application isolation is another significant benefit of using containers. Each container runs in its own isolated environment, reducing the risk of conflicts between applications and improving security. This isolation also makes it easier to manage dependencies and versions for different applications running on the same host. Lastly, Azure containers simplify management and updates. With containerization, you can update applications by replacing the entire container rather than updating individual components. This approach reduces the complexity of managing applications and ensures consistency across all instances of your application. As we delve deeper into Azure Container Services, you'll see how these advantages translate into real-world benefits for your organization, enabling more efficient, scalable, and manageable cloud solutions. When comparing virtual machines, VMs, to containers, it's essential to understand their fundamental differences and use cases. Both technologies offer virtualization solutions, but they approach it from different angles. Virtual machines, as illustrated in our diagram, include a full guest operating system for each VM. This approach provides strong isolation between applications and allows you to run applications that require different operating systems on the same physical hardware. However, this comprehensive virtualization comes at the cost of increased resource usage and longer startup times. Containers, on the other hand, share the host operating system's kernel and run as isolated processes in user space. This lightweight approach offers several advantages. Efficiency. Containers require fewer resources than VMs, allowing you to run more applications on the same hardware. Speed. Containers can start almost instantly, as they don't need to boot an entire OS. Consistency. Containers package the application and its dependencies together, ensuring consistent behavior across different environments. Portability. The self-contained nature of containers makes it easy to move applications between different hosts or cloud platforms. However, containers also have some limitations compared to VMs. Less isolation. While containers provide process and file system isolation, they don't offer the same level of security isolation as VMs. OS constraints. All containers on a host must be compatible with the host's operating system kernel. In practice, many organizations use both VMs and containers, leveraging the strengths of each technology where appropriate. For example, you might use VMs to provide isolation between different departments or clients, and then use containers within those VMs to deploy and manage individual applications efficiently. Azure offers a comprehensive suite of container services designed to meet various needs and use cases. Let's explore the three main offerings: Azure Container Instances, Azure Container Apps, and Azure Kubernetes Service. Azure Container Instances, ACI, represents the simplest and fastest way to run containers in Azure. As a Platform as a Service, PaaS offering, ACI allows you to upload your containers and run them without managing any underlying infrastructure. This service is ideal for scenarios where you need to quickly deploy containers without the overhead of orchestration. Use cases for ACI include simple applications, batch jobs, and CI/CD pipelines. Azure Container Apps builds upon the simplicity of container instances while offering additional features crucial for production workloads. Like ACI, it's a PaaS offering that abstracts away infrastructure management. However, container apps provide built-in load balancing and auto-scaling capabilities. This makes them suitable for more complex applications that require high availability and the ability to handle variable loads efficiently. Container apps are an excellent choice for microservices architectures and applications that need to scale based on various triggers, including HTTP requests and event-driven workloads. Azure Kubernetes Service, AKS, sits at the top of the container service hierarchy, offering a fully managed Kubernetes orchestration service. While it requires more setup and management compared to the other options, AKS provides the most flexibility and control over your container environment, It's ideal for large-scale deployments, complex microservices architectures, and scenarios where you need fine-grained control over your container infrastructure. AKS handles critical tasks such as health monitoring, maintenance and scaling of your Kubernetes cluster, allowing you to focus on application development rather than infrastructure management. When deciding which service to use, consider factors such as the complexity of your application, scalability requirements. Azure Functions represents a paradigm shift in cloud computing, offering a serverless approach that allows developers to focus solely on writing code that matters. This innovative service from Microsoft Azure eliminates the need for managing complex infrastructure, enabling you to build and deploy applications more efficiently. At its core, Azure Functions is an event-driven platform. This means that your code is executed in response to specific triggers or events, such as HTTP requests, database changes, or messages from other Azure services. The beauty of this model lies in its efficiency. Your functions spring to life when needed and remain dormant when not in use. Unlike traditional cloud computing models, where you might need to provision and maintain virtual machines or containers, Azure Functions handles all the underlying infrastructure for you. This serverless architecture not only simplifies your development process, but also optimizes resource utilization. You're no longer paying for idle resources. Instead, you're charged based on the actual execution time and resources consumed by your functions. The event-driven nature of Azure Functions brings unparalleled scalability to your applications. As the demand for your application fluctuates, Azure automatically scales the resources allocated to your functions. This elasticity ensures that your application can handle sudden spikes in traffic without any manual intervention, while also scaling down during periods of low activity to minimize costs. By leveraging Azure Functions, you're embracing a modern, efficient approach to application development. It allows you to break down your application into smaller, more manageable pieces of logic, each responding to specific events. This granular approach not only makes your code more modular and easier to maintain, but also allows for rapid development and deployment of new features. Serverless computing in Azure represents a revolutionary approach to building and deploying applications in the cloud. This paradigm shift allows developers to focus entirely on writing code that delivers business value without the burden of managing underlying infrastructure. Azure offers a comprehensive suite of serverless services, each designed to address specific aspects of application development and deployment. At the heart of Azure's serverless offerings is Azure Functions. This service enables you to write and deploy individual pieces of code that respond to specific events, whether it's processing data streams, responding to database changes, or handling HTTP requests. Azure Functions provides a flexible and scalable environment for your event-driven code. Complementing Azure Functions is Azure Logic Apps, a powerful tool for automating workflows and business processes. Logic Apps allows you to visually design and implement complex processes that integrate various services and APIs. From simple task automation to sophisticated enterprise integration scenarios, Logic Apps offers a no-code, low-code approach to process orchestration. Azure Event Grid plays a crucial role in the serverless ecosystem by providing intelligent event routing. It acts as a central hub for your application's events, allowing different parts of your system to publish and subscribe to events seamlessly. This service enables you to build highly responsive, event-driven architectures that can scale effortlessly. For scenarios requiring robust message handling and queuing, Azure Service Bus steps in as a fully managed message broker service. It provides reliable message queuing and publish-subscribe topics, enabling you to decouple different parts of your application and ensure reliable communication between components, even under high load or intermittent connectivity. Together, these serverless services in Azure form a powerful toolkit that enables developers to build sophisticated, scalable, and resilient applications. By abstracting away the complexities of infrastructure management, serverless computing allows you to innovate faster, reduce time to market, and optimize costs by paying only for the resources you actually use. Azure Functions offers a range of benefits that make it an attractive choice for developers and organizations looking to build scalable, efficient, and cost-effective applications. Let's explore these advantages in more detail. First and foremost, Azure Functions allows developers to focus on code, not infrastructure. This means you can concentrate on writing the business logic that matters most to your application without getting bogged down in the complexities of server management, patching, or scaling. Azure takes care of all the underlying infrastructure, freeing you to be more productive and innovative. Azure Functions excels in event-driven scenarios. Whether you're responding to HTTP requests, database changes, or messages from other Azure services, Functions provides a flexible and responsive environment. This event-driven architecture allows your application to react quickly to changes and triggers, enabling real-time processing and improved user experiences. One of the most powerful features of Azure Functions is its ability to scale automatically based on demand. As your application's workload increases, Azure Functions seamlessly scales out to handle the additional load. When demand decreases, it scales back down just as smoothly. This automatic scaling ensures that your application remains responsive under varying loads while optimizing resource usage. Cost efficiency is another significant advantage of Azure Functions. With its pay-per-execution model, you only pay for the compute time your functions actually use. This granular billing approach can lead to substantial cost savings, especially for applications with variable or intermittent workloads. You're not paying for idle resources, making it an economical choice for many scenarios. Azure Functions offers flexibility in terms of state management. By default, functions are stateless, which is ideal for many scenarios where each function execution is independent. However, when you need to maintain state across function executions, you can use durable functions. This feature allows you to write stateful functions in a serverless environment, opening up possibilities for more complex workflows and long-running processes. Lastly, Azure Functions provides flexibility in deployment environments. While it's primarily designed as a serverless platform, you have the option to deploy your functions in various environments. This includes running them on dedicated VMs, in containers, or even on-premises. This flexibility ensures that as your application's needs evolve, you can adapt your deployment strategy accordingly without having to rewrite your functions. When it comes to hosting applications in Azure, developers have several robust options at their disposal. Each option caters to different needs and scenarios, providing flexibility in how you deploy and manage your applications. Virtual machines, VMs, stand out as a familiar and versatile choice. They offer maximum control over the hosting environment, allowing you to configure it precisely to your specifications. This option is particularly appealing if you're transitioning from on-premises infrastructure to the cloud, as it closely mirrors traditional server setups. Containers represent a more modern and lightweight approach to application hosting. They provide excellent isolation for different components of your application, making it easier to manage and scale individual services. Containers are highly portable and can significantly streamline your deployment process, especially in microservices architectures. Azure App Service emerges as a powerful platform as a service PaaS solution. It abstracts away much of the infrastructure management, allowing you to focus solely on your application code. App Service supports a wide range of programming languages and frameworks, making it a versatile choice for web applications, APIs, and mobile backends. Azure App Service stands out as a powerful and flexible platform as a service PaaS solution within the Azure ecosystem. This HTTP-based service is designed to streamline the process of hosting web applications, RESTful APIs, and mobile backends, allowing developers to focus on writing code rather than managing infrastructure. One of the key strengths of Azure App Service is its language agnosticism. It provides robust support for a wide array of programming languages, including but not limited to .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. This versatility ensures that development teams can leverage their existing skills and preferred technologies when building applications for Azure. Flexibility extends beyond just language support. Azure App Service is equally comfortable hosting applications on both Windows and Linux environments, giving you the freedom to choose the operating system that best suits your application's needs. Automation is at the heart of modern DevOps practices, and Azure App Service fully embraces this philosophy. It offers seamless integration with popular version control systems like GitHub, Azure DevOps, or any Git repository. This integration enables automated deployments, supporting a continuous integration and continuous deployment (CI/CD) model that can significantly accelerate your development lifecycle. Scalability and high availability are critical concerns for any production application. Azure App Service addresses these needs out of the box, offering automatic scaling capabilities that can adjust your application's resources based on demand. This ensures that your application remains responsive under varying load conditions without requiring manual intervention. By abstracting away the complexities of infrastructure management, Azure App Service allows your team to channel their energy and resources into what really matters, building and improving your application. Microsoft takes care of the underlying infrastructure, security patches, and platform updates, providing you with a stable and secure environment for your applications. Azure App Service offers a versatile platform capable of hosting a wide range of web-oriented applications. This flexibility allows developers to leverage a single robust infrastructure for various app service styles, each tailored to specific needs while sharing common benefits. The primary types of app services supported by Azure App Service include web apps. These are the foundation of app service, designed to host full-fledged web applications. Whether you're building a complex e-commerce site or a simple blog, web apps provide the necessary tools and infrastructure. API apps. Focused on hosting RESTful APIs, these apps facilitate the creation of back-end services for mobile and web applications. They offer seamless integration with various data sources and services. Web jobs. These are background processing tasks that can be run on demand, continuously or on a schedule. Web jobs are perfect for handling tasks like image processing or queue processing in the background. Mobile apps. Tailored for building back-end services for mobile applications, these apps offer features like data synchronization, authentication, and push notifications out of the box. What sets Azure App Service apart is that all these app types share the same underlying infrastructure, which brings several key advantages. Integrated deployment and management. App Service seamlessly integrates with popular development tools and source control systems, streamlining the deployment process and simplifying ongoing management tasks. Secured endpoints. Security is a top priority in App Service. It provides built-in authentication and authorization capabilities, allowing you to secure your application endpoints with minimal effort. Scalability. App Service can quickly scale to handle high traffic loads. Whether it's a sudden spike in visitors or a steady increase in users, the platform can automatically adjust resources to maintain performance. High availability. With built-in load balancing and traffic manager, App Service ensures your applications remain available and responsive, even during peak usage times or in the event of hardware failures. By offering this shared set of benefits across different app types, Azure App Service simplifies the hosting and management of web-oriented applications. Developers can focus on building feature-rich applications while leaving the complexities of infrastructure management to the platform. This combination of flexibility and robust features makes App Service an ideal choice for a wide range of web application hosting scenarios. Azure App Service offers a versatile platform capable of hosting various types of applications, each designed to meet specific development needs. Let's explore each type in detail. Web apps. Web apps in Azure App Service provide a robust environment for hosting web applications. Key features include full support for multiple programming languages and frameworks, including ASP.NET, ASP.NET Core, Java, Ruby, Node.js, PHP, and Python. Flexibility to choose between Windows or Linux as the host operating system, allowing developers to work in their preferred environment. Scalability and performance optimization built into the platform, ensuring your web applications can handle varying loads efficiently. API apps. API apps are tailored for building and hosting RESTful web services. Notable aspects include the ability to develop APIs using your preferred language and framework, offering flexibility in implementation. Full Swagger support, which simplifies API documentation and client integration. Option to package and publish your API in Azure Marketplace, potentially monetizing your work. Compatibility with any HTTP or HTTPS-based client, ensuring wide accessibility and integration possibilities. Web jobs. Web jobs offer a way to run background processes alongside your web apps. Key points include support for various file types, including executables, .exe, Java, PHP, Python, or Node.js programs, as well as scripts, CMD, ABAT, PowerShell, or Bash. Flexible execution options. Web jobs can be scheduled or triggered by events, ideal for handling background tasks as part of your application logic, such as queue processing, log aggregation, or periodic cleanups. Runs in the same context as your web app, API app, or mobile app, ensuring integrated performance and resource management. Mobile apps. The mobile apps feature simplifies the process of building back-end services for mobile applications. It offers quick setup of back-end services for iOS and Android apps through the Azure portal. Built-in capability to store mobile app data in a cloud-based SQL database, ensuring data persistence and accessibility. Authentication services supporting common social providers like Microsoft Account, Google, Twitter, and Facebook. Push notification services to keep mobile users engaged and informed. The ability to execute custom backend logic using Sequence or Node.js, allowing for complex server-side operations. SDK support for native iOS and Android development, as well as cross-platform frameworks like Xamarin and React Native. Azure Virtual Networking serves as the backbone of cloud-based infrastructure, enabling seamless communication between various Azure resources and external systems. At its core, an Azure Virtual Network acts as an extension of your on-premises network, providing a secure and flexible environment for your cloud resources. One of the primary advantages of Azure Virtual Networks is the ability to create isolated and segmented environments. This feature allows you to organize your resources into logical groups, enhancing security and simplifying management. By leveraging subnets, you can further divide your network space, applying specific security policies and access controls to each segment. Internet communications are facilitated through public endpoints, which are assigned public IP addresses. These endpoints enable your resources to be accessible from anywhere in the world, making them ideal for public-facing applications and services. Within the Azure ecosystem, virtual networks enable efficient communication between various Azure resources. This inter-resource connectivity allows you to create complex, multi-tiered applications while maintaining security and performance. For hybrid cloud scenarios, Azure Virtual Networks offer robust on-premises connectivity options. Through VPN gateways or express route connections, you can establish secure and reliable links between your Azure environment and your local data centers, ensuring seamless integration of cloud and on-premises resources. Azure Virtual Networking offers a powerful set of features that enable you to build secure, scalable, and flexible network architectures in the cloud. Let's delve into some key aspects of Azure networking. Isolation and segmentation form the foundation of Azure Virtual Networks. You have the ability to create multiple isolated virtual networks within your Azure environment. Each virtual network is assigned a private IP address space, which can be defined using either public or private IP address ranges. It's important to note that this IP range is confined to the virtual network and isn't routable over the Internet, ensuring a level of inherent security. To further organize your network resources, you can divide the IP address space into subnets. This allows you to allocate specific portions of your address space to different parts of your application or infrastructure, enhancing manageability and security. For instance, you might create separate subnets for your web servers, application servers, and database servers. When it comes to name resolution within your virtual network, Azure provides flexibility. You can utilize the built-in name resolution service provided by Azure, which is suitable for many scenarios. Alternatively, if you have specific DNS requirements, you have the option to configure your virtual network to use either an internal or external DNS server of your choice. Enabling Internet communications for your Azure resources is straightforward. You can assign a public IP address directly to an Azure resource, making it accessible from the Internet. Another approach is to place the resource behind a public load balancer, which can provide additional benefits such as high availability and improved security. Communication between Azure resources is a crucial aspect of many cloud architectures. Azure offers two primary methods to enable secure inter-resource communication. First, virtual networks can connect not only virtual machines, but also other Azure resources, such as app service environments, Azure Kubernetes service clusters, and virtual machine scale sets. This allows you to create complex multi-tier applications within a single virtual network. The second method involves using service endpoints. These endpoints enable you to connect to other Azure resource types, such as Azure SQL databases and storage accounts, from within your virtual network. This approach enhances security by allowing you to restrict access to these resources to only the virtual networks you specify, while also optimizing the routing path between your resources. Azure Virtual Networks offer powerful capabilities for connecting your on-premises resources to your cloud infrastructure. This hybrid network approach allows you to create a seamless environment that spans both your local and cloud deployments. Let's explore the three primary mechanisms for establishing this connectivity. Point-to-site VPN connections. This method is ideal for individual remote users who need to access resources in Azure. It establishes an encrypted VPN connection from a client computer to an Azure virtual network. This approach is particularly useful for telecommuters or field personnel who require secure access to cloud resources. The connection is initiated by the client computer, making it a flexible solution for mobile workers. Site-to-site VPN connections. This approach links your on-premises VPN device or gateway directly to the Azure VPN gateway in a virtual network. It creates an encrypted tunnel over the Internet, allowing your Azure resources to appear as if they're on the local network. This method is excellent for organizations that want to extend their on-premises network to the cloud, enabling seamless communication between on-premises and Azure-hosted resources. Azure ExpressRoute. For enterprises requiring higher bandwidth and enhanced security, ExpressRoute provides a dedicated private connection to Azure that bypasses the public Internet entirely. This service offers more reliable and consistent network performance, lower latencies, and higher security compared to typical connections over the Internet. ExpressRoute is particularly beneficial for organizations with strict regulatory requirements or those handling large volumes of data. Azure provides flexible and powerful options for controlling how network traffic is routed within your virtual networks and between Azure and on-premises environments. Understanding these routing mechanisms is crucial for optimizing network performance and security. By default, Azure implements a robust routing system that facilitates communication between subnets in connected virtual networks, on-premises networks, and the Internet. This default routing ensures that resources within your Azure environment can communicate seamlessly without additional configuration. However, there are scenarios where you might need more granular control over traffic flow. Custom route tables offer a solution for defining specific rules about how traffic should be directed. These tables allow you to override Azure's default routing behavior, giving you precise control over packet routing between subnets. For instance, you might want to route all traffic from one subnet through a Network Virtual Appliance (NVA) for inspection before it reaches its destination. Custom route tables make this level of traffic management possible. Border Gateway Protocol (BGP) comes into play when you need to integrate Azure routing with your on-premises network infrastructure. BGP is a standard routing protocol used to exchange routing information between networks. In Azure, BGP works in conjunction with VPN gateways, Azure Route Server, or Azure ExpressRoute to propagate on-premises BGP routes to Azure virtual networks. This integration enables seamless communication between your on-premises resources and Azure-hosted services. By leveraging these routing capabilities, you can create sophisticated network topologies that meet your specific requirements for security, performance, and compliance. Whether you're implementing a simple subnet-to-subnet routing rule or orchestrating complex hybrid network scenarios, Azure's routing features provide the flexibility and control you need to optimize your network architecture. Azure provides robust mechanisms for filtering network traffic within virtual networks, enabling you to implement sophisticated security policies and control the flow of data between resources. Two primary approaches for traffic filtering in Azure are Network Security Groups, NSGs, and Network Virtual Appliances, NVAs. Network security groups act as built-in firewalls for your Azure resources. They allow you to define granular rules that control inbound and outbound traffic to network interfaces, VMs, and subnets. With NSGs, you can create security rules based on factors such as source and destination IP addresses, ports, and protocols. This level of control allows you to implement the principle of least privilege, ensuring that resources only receive the traffic they need to function. For example, you might configure an NSG to allow incoming traffic on ports 80 and 443 for web servers, while blocking all other inbound connections. NSGs can be associated with subnets or individual network interfaces, providing flexibility in how you apply security policies across your virtual network. Network virtual appliances offer a more advanced approach to traffic filtering and network security. NVAs are specialized virtual machines that perform specific network functions, such as firewalls, WAN optimization, or deep packet inspection. These appliances can be deployed from the Azure Marketplace or custom-built to meet specific requirements. An NVA acting as a firewall, for instance, can be placed between subnets or at the edge of your virtual network to inspect and filter traffic based on complex rules and policies. This approach allows for more sophisticated traffic analysis and security measures, such as intrusion detection and prevention, application layer filtering, and URL filtering. By combining NSGs and NVAs, you can create a layered security approach in your Azure environment. NSGs can provide broad, network-level protection, while NVAs offer deep, application-specific security. This multi-tiered strategy helps ensure that your Azure resources are protected against a wide range of potential threats and unauthorized access attempts. Azure provides powerful capabilities for connecting virtual networks, enabling you to create complex, global network architectures that span multiple regions and address spaces. Two key features that facilitate this connectivity are virtual network peering and user-defined routes, UDR. Virtual network peering allows you to seamlessly connect two Azure virtual networks, creating a direct private connection that leverages Microsoft's backbone infrastructure. This peering can occur between networks in the same region, different regions, or even across different Azure Active Directory tenants. The benefits of VNet peering are numerous. Low latency, high bandwidth connections between resources in different virtual networks. The ability to share resources across virtual networks. Data transfer between peered networks remains on the Microsoft backbone network, never traversing the public internet, thus enhancing security. No downtime to resources when creating the peering connection. Peering is particularly useful in scenarios where you need to create hub-and-spoke network topologies, isolate workloads in separate VNets, while maintaining connectivity, or connect resources across different Azure regions. User-defined routes, UDR, complement VNet peering by giving you granular control over the flow of traffic between subnets and virtual networks. With UDRs, you can override Azure's default system routes or add new custom routes. This capability is crucial for scenarios such as forcing traffic through a network virtual appliance, NVA, for inspection or filtering, preventing certain subnets from communicating directly with each other, directing traffic to on-premises networks through a specific gateway or VPN connection. By combining VNet peering and UDRs, you can create a global interconnected network that spans multiple Azure regions. This approach allows you to design network architectures that balance performance, security, and compliance requirements across your entire Azure footprint. Whether you're connecting resources across continents or implementing complex routing policies within a single region, these Azure networking features provide the flexibility and control you need to build sophisticated enterprise-grade network solutions. Azure Virtual Private Networks, or VPNs, are a cornerstone of secure cloud networking. These sophisticated tools create encrypted tunnels within other networks, typically the public internet, to facilitate safe communication between trusted private networks. This technology is crucial in today's interconnected digital landscape, where sensitive data often needs to traverse untrusted networks. At its core, an Azure VPN establishes a secure, encrypted connection. This connection acts as a protective shield, encapsulating your data as it travels across the potentially hostile terrain of public networks. By doing so, Azure VPNs effectively neutralize threats such as eavesdropping or data interception, ensuring that your information remains confidential and intact. One of the primary use cases for Azure VPNs is connecting geographically dispersed private networks. For instance, a multinational corporation might use an Azure VPN to securely link its branch offices across different countries. This setup allows employees to access resources as if they were on the same local network, regardless of their physical location. The beauty of Azure VPNs lies in their ability to create a secure environment for sharing sensitive information. Whether you're transmitting financial data, confidential customer information, or proprietary business strategies, Azure VPNs provide the necessary safeguards to maintain data integrity and confidentiality. In essence, Azure VPNs serve as a vital bridge, enabling organizations to extend their private networks across the vast expanse of the public internet, while maintaining the security and integrity of a closed, private network. This capability is invaluable in our increasingly cloud-centric world, where the ability to connect securely across vast distances is not just an advantage, but a necessity. Azure offers two primary types of VPNs, each designed to meet specific connectivity needs: point-to-site (P2S) VPNs and site-to-site (S2S) VPNs. These two options provide flexibility in how you connect your on-premises networks to Azure. Point-to-site VPNs are ideal for individual users who need to connect to Azure virtual networks from remote locations. This type of VPN is particularly useful for telecommuters or employees who frequently travel. With a P2S connection, the VPN client is configured on individual computers, allowing them to securely access resources in Azure as if they were directly connected to the corporate network. P2S VPNs are relatively easy to set up and don't require dedicated VPN hardware, making them a cost-effective solution for smaller-scale remote access needs. On the other hand, site-to-site VPNs are designed to connect entire on-premises networks to Azure virtual networks. This type of VPN creates a secure tunnel between your on-premises VPN device or gateway and an Azure VPN gateway. S2S VPNs are ideal for organizations that want to extend their on-premises network into the cloud, creating a hybrid environment where resources can be seamlessly accessed across both locations. While S2S VPNs require more initial setup and hardware investment, they provide a persistent connection that doesn't need to be established separately for each user or device. Both P2S and S2S VPNs use industry-standard encryption protocols to ensure the security of data in transit. They can be configured to use either Internet Protocol Security, IPsec, or Secure Socket Tunneling Protocol, SSTP, depending on your specific requirements and the capabilities of your on-premises equipment. The choice between P2S and S2S VPNs often depends on factors such as the scale of your remote access needs, the number of sites you need to connect, your existing network infrastructure, and your budget. Many organizations use a combination of both types to provide comprehensive, flexible connectivity solutions that meet diverse needs across their business operations. Azure VPN gateways are a critical component in the Azure networking infrastructure, serving as the cornerstone for secure encrypted connections between various network environments. These gateways are a specific type of virtual network gateway designed to facilitate protected data transfer across the Internet. One of the key characteristics of Azure VPN gateways is their deployment model. They are installed in a dedicated subnet within your virtual network, often referred to as the gateway subnet. This isolation ensures that the gateway can operate efficiently and securely without interfering with other resources in your virtual network. Azure VPN gateways enable a variety of connectivity options, making them incredibly versatile. They can connect your on-premises data centers to Azure virtual networks through site-to-site connections, allowing for seamless integration between your local infrastructure and cloud resources. For individual users, they support point-to-site connections, enabling secure remote access to Azure resources from anywhere in the world. Additionally, VPN gateways can facilitate network-to-network connections, linking different Azure virtual networks across regions or subscriptions. Security is paramount in VPN communications, and Azure VPN gateways deliver on this front. All data transfer is encrypted inside a private tunnel as it traverses the Internet. This encryption ensures that your data remains confidential and protected from potential threats or eavesdropping attempts. It's important to note that you can deploy only one VPN gateway in each virtual network. However, this single gateway can be remarkably powerful and flexible. It can connect to multiple locations, including other virtual networks and on-premises data centers, making it a central hub for your network connectivity. When setting up an Azure VPN gateway, you have the choice between two types: policy-based and route-based. This choice significantly impacts how the VPN determines which traffic needs encryption. Policy-based VPN gateways operate by statically specifying the IP addresses of packets that should be encrypted through each tunnel. Every data packet is evaluated against these predefined IP address sets to determine which tunnel it should be sent through. This approach can be useful in specific scenarios where you need very granular control over traffic encryption. On the other hand, route-based gateways take a more dynamic approach. In this model, IPsec tunnels are treated as a network interface or virtual tunnel interface. The routing of packets is determined by IP routing protocols, which can be either static routes or dynamic routing protocols. This method decides which tunnel interface to use for each packet. Route-based VPNs are generally the preferred connection method for on-premises devices due to their resilience to topology changes, such as the creation of new subnets. Route-based VPN gateways are particularly versatile and are recommended for several scenarios. They're ideal for connections between virtual networks, enabling seamless communication across your Azure environment. They also support point-to-site connections, multi-site connections, and can coexist with an Azure ExpressRoute gateway, providing maximum flexibility in your network design. Azure VPN gateways are a crucial component in the Azure networking ecosystem. As a type of virtual network gateway, they serve as the cornerstone for establishing secure, encrypted connections between various network environments. These gateways are deployed in a dedicated subnet within your Azure virtual network, often referred to as the gateway subnet. This isolation ensures that the gateway can operate efficiently and securely without interfering with other resources in your virtual network. One of the key strengths of Azure VPN gateways is their versatility in enabling various connectivity options. Site-to-site connections allow you to link your on-premises data centers directly to your Azure virtual networks. This creates a seamless extension of your local network into the cloud, enabling hybrid cloud scenarios and easy resource access. Point-to-site connections cater to individual devices, allowing remote users to securely access Azure resources from anywhere in the world. This is particularly useful for remote work scenarios or for organizations with a distributed workforce. Network-to-network connections facilitate linking different Azure virtual networks, even across regions or subscriptions. This enables you to create complex multi-region network topologies within Azure. Security is paramount in VPN communications, and Azure VPN gateways deliver on this front. All data transfer is encrypted inside a private tunnel as it traverses the Internet, ensuring that your information remains confidential and protected from potential threats or eavesdropping attempts. It's important to note that you can deploy only one VPN gateway in each virtual network. However, this single gateway can be remarkably powerful and flexible. It can connect to multiple locations, including other virtual networks and on-premises data centers, making it a central hub for your network connectivity. When setting up an Azure VPN gateway, you must choose between two types, policy-based and route-based. This decision is crucial as it determines how the VPN will handle traffic encryption and routing. Policy-based VPN gateways operate on a more static model. They require you to specify the IP addresses of packets that should be encrypted through each tunnel. Every data packet is meticulously evaluated against these predefined IP address sets to determine which tunnel it should be sent through. This approach offers very granular control over traffic encryption, but can be less flexible in dynamic network environments. On the other hand, route-based gateways take a more dynamic approach. In this model, IPsec tunnels are treated as a network interface or virtual tunnel interface. The routing of packets is determined by IP routing protocols, which can be either static routes or dynamic routing protocols. This method decides which tunnel interface to use for each packet based on the current network topology and routing tables. Route-based VPNs are generally the preferred connection method for on-premises devices due to their resilience to topology changes. For instance, if you create new subnets in your Azure virtual network, you don't need to update the on-premises VPN configuration to account for these changes. The routing protocols will automatically adapt to the new network layout. It's worth noting that regardless of which VPN type you choose, Azure uses a pre-shared key for authentication. This key is a secret that's shared between Azure and your on-premises VPN device in advance, providing a secure method of establishing the initial trust between the two endpoints. The choice between policy-based and route-based VPNs often depends on your specific network requirements, the capabilities of your on-premises VPN devices, and your future network expansion plans. Route-based VPNs are particularly recommended for scenarios involving connections between virtual networks, point-to-site connections, multi-site connections, or when you need coexistence with an Azure Express Route gateway. Understanding these two types of VPN gateways and their characteristics will help you make an informed decision when designing your Azure network architecture, ensuring that you choose the option that best fits your organization's needs and future growth plans. Azure Express Route stands as a cornerstone in Microsoft's cloud connectivity solutions, offering a secure and reliable bridge between on-premises networks and the vast Microsoft cloud ecosystem. This innovative service allows organizations to extend their local network infrastructure directly into the Microsoft Cloud, bypassing the public internet entirely. At its core, ExpressRoute provides a dedicated private connection to Microsoft's cloud services, including Azure and Microsoft 365. This direct link ensures higher reliability, faster speeds, and more consistent latencies compared to typical internet-based connections. For businesses dealing with sensitive data or those requiring guaranteed performance, ExpressRoute offers an unparalleled solution. The beauty of ExpressRoute lies in its flexibility. It caters to various connectivity models, accommodating different organizational needs and existing network architectures. Whether you're operating from multiple office locations or managing large-scale data centers, ExpressRoute can be tailored to fit your specific requirements. One of the standout features of ExpressRoute is its enhanced security posture. By circumventing the public internet, it significantly reduces exposure to potential cyber threats, offering peace of mind for organizations handling critical or sensitive workloads. ExpressRoute brings a host of features and benefits that set it apart in the realm of cloud connectivity solutions. Foremost among these is its ability to provide global connectivity across all Microsoft Cloud Services regions. This expansive reach ensures that organizations can access their resources and data from virtually anywhere in the world, maintaining consistency in their operations regardless of geographical boundaries. A key technical feature of ExpressRoute is its use of Border Gateway Protocol, BGP, for dynamic routing. BGP allows for intelligent path selection and automatic failover, enhancing the reliability and resilience of your network connection. This dynamic routing capability ensures that your data always takes the most efficient path, optimizing performance and reducing latency. Redundancy is built into the very fabric of ExpressRoute. Each peering location is designed with multiple connection points, providing a fail-safe mechanism that significantly reduces the risk of connectivity issues. This built-in redundancy translates to higher uptime and improved business continuity, critical factors for organizations relying heavily on cloud services. ExpressRoute also shines in its ability to deliver consistent network performance. Unlike internet-based connections that can suffer from congestion and variable latency, ExpressRoute provides a dedicated private connection. This results in more predictable and reliable performance, which is particularly crucial for latency-sensitive applications or large-scale data transfers. From a financial perspective, ExpressRoute often proves cost-effective for high-bandwidth scenarios. While the initial setup may require investment, organizations with high data transfer needs often find that ExpressRoute's pricing model results in significant cost savings over time compared to traditional internet-based connections. Azure ExpressRoute offers a comprehensive connectivity solution providing direct and secure access to a wide array of Microsoft Cloud services. This direct access extends to crucial productivity tools such as Microsoft Office 365 and Dynamics 365, as well as core Azure services, including virtual machines, Azure Cosmos DB, and Azure Storage. By enabling this direct connection, ExpressRoute ensures that organizations can leverage the full power of Microsoft's cloud ecosystem with enhanced performance and security. A standout feature of ExpressRoute is its global connectivity capabilities, exemplified by ExpressRoute Global Reach. This feature allows organizations to create a global network infrastructure by connecting their ExpressRoute circuits. Imagine a scenario where a company has an office in Asia and a data center in Europe, both with separate ExpressRoute circuits. With global reach, these two facilities can communicate directly through Microsoft's global network, bypassing the public internet entirely. This capability not only enhances security, but also significantly improves data transfer speeds and reliability across geographically dispersed locations. At the heart of ExpressRoute's networking prowess lies its use of Border Gateway Protocol, BGP, for dynamic routing. BGP serves as the backbone for exchanging routing information between on-premises networks and Azure resources. This dynamic routing capability ensures that network paths are always optimized, adapting in real time to network conditions and changes. For organizations, this translates to more efficient data transfer, reduced latency, and improved overall network performance. Reliability is a cornerstone of ExpressRoute's design, with built-in redundancy as a key feature. Microsoft works closely with connectivity providers to ensure that all connections to the Microsoft network are established with high availability in mind. Each provider utilizes redundant devices, creating multiple paths for data to flow, and significantly reducing the risk of connectivity issues. Furthermore, organizations have the option to configure multiple ExpressRoute circuits, adding an extra layer of redundancy to their network architecture. This multi-layered approach to redundancy ensures that businesses can maintain consistent access to their cloud resources, minimizing downtime and enhancing business continuity. Azure ExpressRoute offers a versatile range of connectivity models designed to accommodate diverse organizational needs and existing network infrastructures. These models provide flexibility in how businesses can establish their dedicated connection to the Microsoft Cloud, ensuring that there's a suitable option regardless of an organization's size, location, or technical requirements. The Cloud Exchange colocation model is ideal for organizations that have a presence in facilities that are already colocated with a cloud exchange. In this scenario, if your data center, office, or other facility is physically colocated at a cloud exchange, such as an internet service provider, you can request a virtual cross-connect to the Microsoft Cloud. This model offers a straightforward and efficient way to establish a high-speed, low-latency connection to Azure services. For organizations that prefer a more direct approach, the point-to-point Ethernet connection model provides a dedicated private link between your facility and the Microsoft Cloud. This model is particularly useful for businesses that require a high degree of control over their network connection and want to ensure consistent performance for their cloud-based workloads. The any-to-any connection model offers a great deal of flexibility, allowing you to integrate your wide area network, WAN, directly with Azure. This model is particularly beneficial for organizations with multiple office locations or branch offices. It enables you to create connections to Azure that function similarly to the connections between your data center and branch offices, effectively extending your WAN into the cloud. For organizations requiring the highest level of bandwidth and the lowest latency, the option to connect directly from ExpressRoute sites is available. This model allows you to connect directly into Microsoft's global network at strategically located peering points distributed worldwide. ExpressRoute Direct, a feature of this model, provides dual 100 Gbps or 10 Gbps connectivity, supporting active-active connectivity at scale. This option is ideal for organizations with massive data transfer requirements or those running latency-sensitive applications that demand the highest level of network performance. Each of these connectivity models offers unique benefits, catering to different organizational needs, technical requirements, and geographical constraints. By providing this range of options, ExpressRoute ensures that organizations can choose the most suitable an efficient way to establish their dedicated connection to the Microsoft Cloud, optimizing their network performance and enhancing their overall cloud experience. Security is a paramount concern when it comes to cloud connectivity, and Azure ExpressRoute addresses this concern head-on with its architecture and design. The primary security advantage of ExpressRoute lies in its ability to provide a private connection between your on-premises infrastructure and Azure, effectively bypassing the public internet. By routing your data through a dedicated private connection, ExpressRoute significantly reduces the security risks typically associated with internet-based communications. This approach minimizes exposure to potential threats that are common on the public internet, such as man-in-the-middle attacks, DDoS attacks, and other forms of malicious activity. The private nature of the connection also helps in maintaining the confidentiality and integrity of your data as it travels between your on-premises environment and Azure. ExpressRoute establishes a direct link from your on-premises infrastructure to your Azure infrastructure. This direct connection not only enhances security, but also provides better control over your network traffic. It allows you to implement your own security policies and measures more effectively, as you have a clearer view of the network path your data is taking. However, it's important to note that while ExpressRoute provides a secure path for most of your Azure-related traffic, there are some Azure services that still rely on the public internet for certain functions. These include DNS queries, certificate revocation list checking, and requests to Azure Content Delivery Network. While these services use the public internet, they typically involve less sensitive data and have their own security measures in place. For DNS queries, while they do traverse the public internet, you can enhance security by using Azure Private DNS zones for your virtual networks. This allows you to use your own custom domain names within your virtual networks without exposing that information to the public internet. Certificate revocation list checking is a critical security function that helps ensure the validity of digital certificates. This process typically needs to access public certificate authorities, which necessitates the use of public internet connections. Azure Content Delivery Network requests also use the public internet, as CDNs are designed to deliver content from edge locations that are geographically closer to end users, improving performance for globally distributed applications. While these exceptions exist, the core of your data transfer, including all your business-critical information and applications, still benefits from the enhanced security of the private ExpressRoute connection. This hybrid approach allows for optimal security where it matters most, while still enabling the full functionality of Azure services that require some level of public internet access. Azure DNS represents a significant leap forward in domain management for cloud-based applications and services. As we delve into the world of Azure DNS, it's crucial to understand its role and benefits in the broader context of cloud computing. At its core, Azure DNS is a hosting service designed specifically for DNS domains. It leverages the robust and globally distributed infrastructure of Microsoft Azure to provide efficient and reliable name resolution. This means that when you host your domains on Azure DNS, you're tapping into a network that's built to handle the demands of modern, cloud-scale applications. One of the key advantages of Azure DNS is its seamless integration with other Azure services. This integration allows you to manage your DNS records using the same credentials, APIs, tools, and billing as your other Azure services. For organizations already utilizing Azure for other aspects of their infrastructure, this integration streamlines management processes and reduces the complexity of maintaining separate systems for DNS management. The scalability of Azure DNS is another noteworthy feature. Whether you're managing a handful of domains or thousands, Azure DNS is designed to grow with your needs. This scalability ensures that as your organization expands, your DNS infrastructure can keep pace without requiring significant changes or migrations. Reliability is paramount when it comes to DNS services, and Azure DNS doesn't disappoint. By leveraging Azure's global network of name servers, Azure DNS provides a high level of availability and fast performance for your domains. This reliability is crucial for maintaining the accessibility and user experience of your web applications and services. Azure DNS offers a host of benefits that make it an attractive choice for organizations looking to streamline their DNS management in the cloud. Let's delve into these advantages to understand how Azure DNS can enhance your domain hosting experience. Reliability and performance stand at the forefront of Azure DNS benefits. By leveraging Azure's global network of name servers, Azure DNS ensures high availability and rapid response times. This global distribution means that DNS queries are answered by the closest available DNS server, reducing latency and improving the overall user experience for your applications and services. Security is another crucial aspect where Azure DNS shines. It integrates seamlessly with Azure Role-Based Access Control, RBAC, allowing you to manage access to your DNS resources with granular precision. This integration means you can specify exactly who in your organization can access and modify DNS records, enhancing your overall security posture. Ease of use is a significant advantage of Azure DNS. The service is designed with user-friendliness in mind, offering an intuitive interface through the Azure Portal, Azure PowerShell, or the Azure CLI. This ease of use extends to its integration with other Azure services, allowing for streamlined management of your entire cloud infrastructure from a single platform. Azure DNS also offers support for customizable virtual networks. This feature allows you to use custom DNS servers and configure DNS settings for your Azure virtual networks. It's particularly useful for scenarios where you need to resolve names between virtual networks or from on-premises to Azure. Lastly, Azure DNS supports alias records, a powerful feature that allows you to point your DNS records to Azure resources. This means you can have your DNS records automatically update when the IP addresses of your Azure resources change, ensuring your domains always point to the correct resources without manual intervention. Azure DNS sets a high standard for reliability and performance in domain management. By leveraging Microsoft's global network of DNS name servers, Azure DNS ensures that your domains are always accessible and responsive, regardless of geographic location or network conditions. The foundation of Azure DNS's reliability lies in its use of Azure's expansive infrastructure. Your DNS domains are hosted on a distributed network of name servers, providing built-in redundancy and fault tolerance. This architecture ensures high availability, minimizing the risk of downtime or service interruptions that could impact your applications or services. A key feature enhancing both reliability and performance is Azure DNS's use of Anycast networking. This advanced routing technique allows DNS queries to be answered by the nearest available DNS server. The result is significantly reduced latency as user requests are routed to the closest point of presence, ensuring fast response times regardless of the user's location. Performance is further boosted by Azure's global reach. With data centers strategically located around the world, Azure DNS can provide low-latency name resolution for users across different geographic regions. This global presence is particularly beneficial for organizations with an international user base or those looking to expand their reach to new markets. Azure DNS is designed to automatically scale to meet demand. Whether you're managing a handful of domains or thousands, the service can effortlessly handle increasing query volumes without requiring manual intervention. This scalability ensures consistent performance even as your DNS needs grow over time. The combination of global distribution, Anycast networking and automatic scaling makes Azure DNS a robust and high-performing solution for organizations of all sizes. Azure DNS takes flexibility to the next level with its support for customizable virtual networks and private DNS domains. This feature addresses a common challenge in cloud environments: the need for custom domain names within private networks. In traditional Azure setups, you're often limited to using Azure-provided domain names for resources within your virtual networks. While functional, these names can be cumbersome and don't always align with an organization's naming conventions or branding guidelines. Azure DNS changes this paradigm by allowing you to use your own custom domain names in your private virtual networks. This capability offers several advantages. Firstly, it allows for more intuitive and meaningful resource naming within your private Azure environment. Instead of using auto-generated names, you can create a naming structure that makes sense for your organization, improving clarity and ease of management. Secondly, custom domain names in private networks can greatly simplify internal communications and application configurations. You can use familiar business-relevant names for your resources, making it easier for your team to remember and work with these resources. Moreover, this feature enhances your ability to mirror your on-premises DNS structure in the cloud. If you're in the process of migrating to Azure or operating in a hybrid environment, you can maintain consistency between your on-premises and cloud-based resources naming conventions. The support for private DNS domains also plays a crucial role in scenarios involving virtual network peering or hybrid networks. It allows for seamless name resolution across connected networks, facilitating smooth communication between resources in different virtual networks or between Azure and on-premises environments. As we delve deeper into Azure DNS configurations, we'll explore practical implementations of custom domain names in private virtual networks. Alias records in Azure DNS represent a significant advancement in DNS management within cloud environments. This feature allows you to create DNS records that directly reference Azure resources, providing a more dynamic and manageable approach to DNS configuration. The power of alias records lies in their ability to automatically update during DNS resolution. When you create an alias record set, it points to a specific Azure resource rather than a static IP address. This means that if the IP address of the underlying resource changes, the alias record set seamlessly updates itself, ensuring that your DNS always points to the correct destination. This functionality is particularly valuable for Azure resources that may have changing IP addresses, such as Azure Public IP addresses, Azure Traffic Manager profiles, or Azure Content Delivery Network (CDN) endpoints. By using alias records, you can maintain stable DNS configurations even as your Azure infrastructure evolves or scales. For instance, if you're using an Azure Public IP address for a web application, you can create an alias record pointing to this resource. If you need to change the public IP address in the future, perhaps due to a migration or infrastructure update, you won't need to update your DNS records manually. The alias record will automatically resolve to the new IP address, ensuring continuous accessibility for your users. Similarly, when used with Azure Traffic Manager, alias records can simplify the management of global traffic routing. As you add or remove endpoints from your Traffic Manager profile, the alias record will always direct users to the appropriate endpoints without requiring manual DNS updates. For CDN endpoints, alias records can ensure that your content is always accessible through your custom domain, even if the underlying CDN configuration changes. The use of alias records not only simplifies DNS management, but also reduces the risk of errors associated with manual DNS updates. It creates a more robust and resilient DNS infrastructure that can adapt to changes in your Azure environment automatically. When working with Azure DNS, it's crucial to understand the distinction between domain name registration and DNS hosting. Azure DNS is designed to provide robust DNS hosting services, but it does not offer domain name registration or purchasing capabilities. To acquire a domain name for use with Azure DNS, you have two primary options. 1. App Service Domains. Microsoft offers domain registration services through Azure App Service. This service allows you to purchase domains directly within the Azure ecosystem, simplifying the process of integrating your domain with other Azure services. 2. Third-party domain name registrars. Alternatively, you can purchase domain names from any accredited domain name registrar. These include well-known providers such as GoDaddy, Namecheap, or Domain.com, among many others. Regardless of where you purchase your domain, once you own it, you can easily host it on Azure DNS. This separation of domain registration and DNS hosting offers you flexibility in managing your domains and DNS records. When you host your purchased domain on Azure DNS, you gain access to all the benefits we've discussed, including high reliability, performance, security features, and integration with other Azure services. You'll be able to manage your DNS records directly within the Azure portal, PowerShell, CLI, or REST API, streamlining your overall domain management process. It's worth noting that while purchasing a domain typically involves an annual fee, hosting your DNS on Azure DNS is billed based on the number of DNS zones and queries. This model can often be more cost-effective, especially for organizations managing multiple domains or those with fluctuating traffic patterns. As we progress through this course, we'll explore the process of setting up Azure DNS for domains purchased through various methods, ensuring you have a comprehensive understanding of how to leverage Azure DNS regardless of where your domains are registered.